All right, here we go. Welcome back to session number 2 on this PySpark Structured Streaming live coding series. I hope people will join soon. Otherwise, I will simply get started so people can review the video after we're done coding here. Please let me know if the video and the audio is working fine. Also, if you have any questions along the way, just ask them while I code. I'm very happy to answer all of the questions that you may have. Otherwise, I will simply get started. Now today, as you may recall from our previous session, we have implemented a simple PySpark structured streaming use case in a test-driven manner, meaning we didn't care about loading data or writing data. We were simply implementing some functionality and some unit tests based on a streaming data frame. Now today we are going to extend this logic a bit by implementing a second use case, analyzing our stream. And we are going to implement an aggregation function. And I've written down the assignment basically here. So first of all, we should find the total order volume per product. And as you may recall from our previous stream, we are going to work with retail data, meaning we have purchase transactions from an online store, for example. Each purchase quantifying an order a user has made. So there will be a number of items and so basically the quantity and the price per item. From that we can derive the total order volume. And also we have a purchasing timestamp. And our assignment today is that we want to find the total order volume and the latest purchasing timestamp from the stream. Let me go back here. So that would be the total order volume, latest purchase timestamp, and that is an aggregation. Basically, we are processing each of the items coming into the stream, but keeping an internal state, which basically would be summing up the total order volume for each purchase and also keeping the latest timestamp. Now we should return the aggregated metrics as a data frame, as a stream, so basically a streaming data frame. And along the way, we will talk about output modes like complete, append, and update, which are the 3 output modes that exist in PySpark Structured Streaming, or generally actually in Spark Structured Streaming. Now streaming is becoming increasingly important for many companies as they want to draw insights from their data as it arrives, rather than in a batch mode where they basically analyze data once a day or a couple of times a day. But the trend is heavily towards running real-time analytics on streaming data. And Spark is a very good, has many advantages, or is a technology which has many advantages for that, because we can actually do batch-oriented analytics. And with the same API, meaning Spark SQL, we can also run streaming analytics without changing the code, meaning making it very valuable for having basically a hybrid model. All right, so I will simply go ahead and start implementing this. First of all, I will go back to our purchase analytics file where we have implemented the filter purchases. And here we want to adopt a test-driven development style again, basically implementing a method which will do this for us. So here we run product aggregations, something like this, and we pass in a data frame, and it should return a data frame. So I like to specify the return types, data frame, and we in turn will make this a static method because it doesn't require anything from that class in which it's contained. So we can simply call it from the unit test. Now here we don't implement anything, we simply return the same data frame, which is obviously not the logic we want to have, but we will implement this later. We will start with the unit test. Okay, so here we have to import the data frame again, or why does it not pick this one up? I have a typo here, should be data frame. So that would be the signature. And that we can call already from the unit test. And in the last session, we have worked on this purchase analytics table test, which is basically the test for our purchase analytics here from that class. And it's called table test because we are using in-memory tables. There are other ways to test streaming functionality because we need to create streaming data frames, but we can reuse most of the code we used here. So we have implemented last time this test filter purchases. So I can simply copy that one and we can adjust it, and we're going to name it test product aggregations. And it will have to, it will go on the same test class here, because this is the test class testing our purchase analytics class. So let's go ahead and define or specify the behavior in the unit test like last time. We don't need these arguments or parameters for our filter. So what we do in a unit test is we specify the input data. So that would be a small test case, and then we want to assert that our functionality produces the right result. So let's leave the two purchase transactions we have defined last time. So we have one purchase which has ID 1. Customer 1 made this purchase, and then there's product ID product 1. So customer 1 bought product 1, 2 items, 10 each in currency, whatever. And then there was also a timestamp. So this one was done on the 1st of June 2024, 10 AM. And the second one was done at 11 AM. So we have a question. I cannot really do it in Databricks. I really enjoy using the IDE, but you can actually do the very same things in Databricks. So everything is transferable actually. I rather work on an IDE properly because, yeah, I'm more productive here than in a browser. But as I said, all of the concepts and everything basically transfers to Databricks. So we have specified 2 transactions. The second one being transaction 2, customer 1 bought product 2, quantities 3, prices 1, and bought at 11 PM. Now the expected is not a filtered, the filtered, we don't have the same transaction filtered, but rather we will receive a different data model because we are running aggregations. So what we want to do is, as I said, we want to find the total order volume and the latest timestamp for each product. So first of all, we want to aggregate by product. So our key will be the product ID. And for product ID, we want to see something. And secondly, we get the total order volume, which will have some value. And we will get the latest purchase timestamp. So that's what will be in our aggregated result, something like this. And now we have to specify which values should each of these fields have based on our input data. So for example, we will see here product P1. And let's make this test, let's adjust this test. Customer 2 bought also product 1 later at a different price. So let's make it the same price but different quantity. So for the total order volume, we want to see 2 times 10 is 20 and 3 times 10 is 30, making 50 in the total order volume across all the purchases. So that's the total order volume for product 1. And the latest purchase timestamp would basically be this one because it's later than the other one. So I'm going to copy that one here. So that's the result we would like to see here actually. Product 1, total order volume 50, latest purchase timestamp 11 AM. All right. Now the rest of the test is basically, or most of the lines here are basically boilerplate code. First of all, we want to create a streaming data frame from our input records, which will be the purchase data frame. So a data frame containing these purchase transaction rows, but it will be a streaming data frame. Therefore, in this method we've implemented last time, we have to pass in the purchase schema, which is defined in the model class. Then we basically call our module which we want to test, or our function, our unit, and that one was product aggregations, and this one takes the streaming data frame but no other parameters, so we can put this also in one line. That would give us the actual streaming data frame, basically the produced result from our unit. Finally, we will use this actual streaming data frame and consume what we have produced as a stream. And here we use the memory table, and we have refactored that one in a method which we can use. So basically what's happening here is we give it the actual streaming data frame containing the result of our aggregations, and we write it to a memory table. We give the query a name, and in the end, then we say query.process all available, which basically processes all the records which are currently available in the input stream. And then we get all the results from that memory table. We retrieve them as dictionaries, and then we return the dictionaries and the query. We will return the query because this one will not terminate. This one will continue running. And in the end of the test, we want to call query.stop. That's why we return the query as well. So that's what's happening here. We get back the actual dictionaries, and then we can run some assertions. So first of all, we want the number of items to match in the expected, so our expected data, that's the result we would like to see. And so there should be as many elements as in the actual dict, so what our stream query has basically produced. And then we basically assert that this record here is actually in the actual result. And then we have verified that we receive exactly the result we have specified in our test here. Now we can go ahead and run this one. And of course the test will fail because we haven't implemented the correct functionality, but we are simply returning the input stream. So that's not the expected behavior. Let's see if it goes, but that's basically a smoke test. After that, we can basically implement our unit, and then the test should run. Let's see, take some time here to start this one. So as expected, the test fails. And it says expected would be one record, but actually we have two, which makes total sense. All right, now let's implement the aggregation, which will make one record out of two records. Now here, as you can see, we will simply use the standard Spark SQL API, which we can use for batch queries as well. So we're simply using the data frame API. So we group by product ID, and then we basically get two aggregations. One being the sum basically of the column quantity times the column price per unit. And then, so that will be the sum. And the default column name for this would basically represent what we're doing here. So it will be sum quantity times price per unit. Therefore, we will provide an alias, basically renaming this column to our desired column name, which will be total order volume. All right, let's clean this one up a bit. That should work because that's in parentheses here. All right, that will be the first one. And then we also have a second one, which will be the max of column purchase timestamp, if that's how it's called. Let me look that up here. Purchase timestamp. And here we want to have an alias as we are specified in the test, latest purchase timestamp, basically. All right, and that will be our result. Now we don't want to return the F here, but we actually want to return this one. Return. So we will actually get 3 columns: the product ID, which is the aggregation key, then the total order volume, and the latest purchase timestamp. And let's see if our test completes now successfully. Let's wait until this one starts. So that would be a test-driven approach. We don't load data, we don't write data. We automate testing by specifying input and output data, and we're using in-memory streams. Now we have a problem here. In the process all as dicts. Let's see what's going wrong. All right, so now we have the analysis exception. Append output mode not supported when there are streaming aggregations on streaming data frames without a watermark. So now we have to talk about the output modes. Previously, we were using the append output mode, which basically produces only records to the output stream, which appends basically all new records to the output stream. But therefore, we will have to use a watermark, as it says here, if we have aggregations. We will talk about watermarks next time. For now, I will simply change the output mode to complete, and therefore, process all as dicts has hard-coded here append output mode. However, as we have our first test still, which uses or which depends on the append output mode, I will introduce a parameter here, output mode, which is a string, and it should be per default append. However, we can pass in some different one if you like. So here we use the output mode. Now the first test will still work correctly, because if we don't pass it in, we will use append. Otherwise, in this case, process all as dicts will use complete, which basically means that we produce when we calculate the aggregations, every time the aggregations change, we put the entire output table, the aggregations table, into the stream again. So every time we get a new record, we'll get a new aggregations table in our stream. So basically we're having a lot of redundant data. But for now, let's work with this one. As we process these 2 records, let's see. Will we get 1 or 2 tables? Probably 2, so we have to adjust the expected to contain 2 rows, one after processing the first, one after processing the second. The other option we have is actually the update mode, which we can also use, which will emit only the row which has been updated actually. Okay, here we go. What do we have? Assertion error. So it says basically the number of items is fine. But here it says this record has not been found in our actual output. So we're having product ID 1, total order volume 50, max purchase timestamp. The latest purchase timestamp, daytime 1st of June, and in our actual result we have a wrong column name. So here you can see the default column name which Spark uses on aggregations or on transformations. So something is wrong with our alias. Let's see. So max column. Aha. So here I've put the parentheses wrong. All right. So now it's correct. Now we apply the max on this column, and then we apply the alias. So let's run this test again. Should be working now. There's another question. So the question is using the Spark function for the F column creation faster than Spark SQL or DuckDB? I don't know exactly what you mean by that. So basically, you're probably referring to this column function here. Let me open up that one. Probably this one. If you mean that, that simply references a column and gives us a column object. So it is Spark SQL. The code we write here is basically Spark SQL, all of that. However, we need to call this function so that we can get a column reference rather than a string. There are different ways to reference columns from a data frame. Calling this function column does not associate a column with a data frame in the first place. Only if we apply this transformation here, for example, to the data frame df, and execute this query, Spark will try to resolve this column name from this data frame. But it's simply referencing a column in this data frame. All right, now our test has completed. So we use the complete output mode here, and we actually only got this result. That's because we basically processing these two items in one single batch, emitting only one aggregation result. So that's why we can test basically how Spark would behave if we had two batches of data by adjusting this test case, which would be the next task for us to do. So we will adjust this test case so that we run this query in two tests, but in two batches. But for now, the query looks fine. So let's go ahead, rename this one single batch. Or should we run it in update mode right away? That will also be fine. No, let's create another test for this. So here we have test product aggregations, 2 batches. So that describes our test. Now we will make the import records a tuple, that one being the first batch, and then we have records 2 also being a list. So we introduce a second list. Now we have a tuple of records. Don't think we need these brackets here. First of all, in the first batch, we leave the 2 purchases here. But now we introduce in the second batch a third one. Let's say ID 3, customer 2 bought product 1 again. Quantity, let's say 2. Price per unit. And actually they're arriving out of order. So let's make this 09. So we want to see still, in the first batch, we want to see basically the same row. For the second row, when we update our table with a new transaction here, we want to see an updated total order volume, but we still want to see the same latest purchasing timestamp, so the max of the timestamp. Therefore, we will have to adjust our expected list as well. So let's call this one here expected 1, expected 2, make this a tuple of lists as well. And as I said before, on product 1, we want to have total order volume, which is different now. So we basically have to add 20, which make it a 70. And the latest purchase timestamp should remain the same. All right. So that would be our input data and output data. Now we have to adjust our test so that we actually run in 2 batches. Okay. Let's get the streaming data frame for records 1. That remains the same. The actual remains the same. Process all as dicks in complete mode can remain the same. And here we basically want to have expected 1 and also here. So that would adjust our test case, but we're still testing the same thing. Now we have to basically do this a second time. So now we don't have to get a new streaming data frame. We simply want to add data. Aha, now we have to change this code here. Because for now we are always overwriting the memory table. So we will have to split this one. The problem is we want to simply append the records to our table and not override it. So we could basically refactor that one as a, but the read stream can remain the same. So we have to split this one into 2 methods. The first would be, we create a data frame from the schema and then we write it to the table. So that one will have to go in its own method, write data to table. And now for our current use case, we don't want to overwrite. So I'm going to introduce mode, which is a string per default overwrite to not break our previous tests. Put the mode here. But we can pass in append as well, which will append this data frame to the table. So that's what we want to use here. And now get streaming df, basically write data to table. It's being called here. That's not what we want. That's not what we want. We want to call, we want to have control over that. So let's remove this one. Then we don't need the records here. Let's put the type here. List. And this is a struct type. The schema we need here. So we need it in both. So this one will simply read our memory table. That one we only have to call once. Get streaming df. Alright. Now we have more fine-grained control over this. Basically, we have to adjust this one now. Basically all the tests. Let's start with this one. Get streaming df. Let's see what we need here. We have to pass in the schema. So first of all, we would like to write to table. So self, write data to table. Here we need to specify the records 1. Then the purchase schema. And then mode override would be fine because that one is the first call. We don't need to return anything. So that writes the records to the table. And then we want to get the streaming df. Now the parameter list has changed. We only need to pass in the schema. And it returns the streaming df. So no records, only the schema. That will give us the streaming df reading from the table. And then we pass this one into our unit. And then we process all as ticks. That's fine. And now we can do the same thing here. So first of all, we want to call self write to table. And now we want to write records to. We need a schema. By hitting Command and P, I can see the parameter list from the IDE. So here we need to purchase.schema as well. And now we don't want to overwrite, but we want to append. So our input table contains these records as well. And we don't have to get the streaming df again because we already have it. We have also already called this function. So the output is a stream, it's still running. So we don't actually have to call this one again. Rather, we simply want to get all the new outputs from the stream. So that's why we call process all as ticks. In complete mode, everything can remain the same. And now we wanna say we override the actual digs. And in here we actually call process all available, which will account for our newest data we have pushed to the table. And therefore we can assert now that we want to have the expected 2 in our actual digs. And also this record should be there. We are running in complete mode, so we're always getting the entire table back. So it should contain only 1 row. So that should be fine. Let me run this test. Now we have to adjust these things here as well. So here we have split this one up. First of all, we need to call self write data to table, records, purchase schema. Override mode is fine, and then get the streaming df, no records, only the schema. Right. Yes. So that one we have to do in the second test as well. Here, write to table, override mode. This line we don't need. And in the third test we have already done it. All right, let's try to execute this one. Thanks for answering the question already. However, I don't have a main method here as well. It's correct, I'm on Python, not on a JVM. But as you do test-driven development, you don't actually have to implement a main method, because the testing framework can be executed without a main method, and we're only running tests here basically. But yeah, as if you want to execute your application without tests, you will have to create a main method if you're on Java or JVM-based languages. All right, let me see what here is happening. So it failed, process all digs again. Cannot call methods on a stopped Spark context. Cannot start query with filter. Yeah, we're trying to start the same query twice, which doesn't make sense. So that's the error here. So we get an illegal argument exception because we're calling the get streaming data or get actual results as dict. There we are starting a query, but we only need to start a query once for the entire test case, even if we try to fetch the records from that query twice. Therefore, we will have to move that out of this method as well. And that's what's written there in the error. So if I go to the process all as dicts, here we are starting a streaming query. So let's move this one out. This one. Move it to a start streaming query method. Actual streaming def that we need, yes. Output mode we also need. And we simply return the query. Here we don't return the query anymore, only the dicts. We don't call this from here. We are calling it write data to table, start streaming df. Then we start the query. So here we start a streaming query. We want to complete output mode. So get the query from here, not from here anymore. And then we want to get all. So then we need to say process all available. So we pass in actual streaming def, the output mode not anymore, but the query. So now our process all as dicts basically tells the query it should process all available, and then it basically fetches all the available records from the query. And that's what we do here now. Start streaming query, actual streaming def, query, like this. And then write data to table. And here we only wanna get, we have to pass this one in and the query, like this. So we had to split up the code a bit to make this, to get basically finer grained access or control over what we're doing here. So here we have to do the same thing as we do here. First we start the streaming query, then we retrieve all the records, so that remains the same. And same in the test above, basically here. Here we don't specify the output mode. We didn't do before neither. Right. Now we have full control over our streams. It's becoming slightly more complicated. We can think later about how we can still refactor this code to be a bit simpler. Let's see what the result will be. So for now we're using complete mode, which will give us every time the output. So probably now our test will fail, because what we get is now 2 output rows, even though we have only one product ID. But we will get 1 output row for product 1, and we will get 1 output row for product 2. We'll get 1 output row for the batch 1 and 1 output row for the batch 2. Okay, here we have a small error. This thing doesn't return the query anymore. We didn't change the code here. So we did it here, but not down there. So start streaming query we don't need. We have it already. Actual dicts we are calling later. Alright. Just not getting back the query because we already have it, which makes total sense. So let's see. As I said before, the test will fail. We get 2 output rows. We only expect 1. So we can rewrite our test so that we expect both expected results basically and the final output. When we want to stick with the complete mode, or we change our test functionality so that we only take the latest row produced and assert that the latest row produced is actually our expected result. So it didn't fail. Let's see, we are running complete mode. Let's do some process all as dicts. So here we have a data frame, actual data frame. Let's show this one. Show and run again. So it will print the data frame to the console here, and we should see the data frame being printed twice. Which test is being run here? Ah, it's the filter. So I was executing the wrong test. Stop it. Let's run it like this then. The one was still selected up here, and I used a shortcut, and that's why the wrong test was executed. Still no questions here. Oh, there's another test running. Should stop this one. I saw that the log was saying it couldn't bind to port 4040. That's why I assumed there was another Spark session in place. And there was actually a old running test still available here. Let's see. So the nice thing is, if we wanted to run our query on a batched data frame, we can simply create a test which will instantiate not a streaming data frame but a complete data frame, and basically run the same functionality that we have implemented here on the entire data frame, and simply write a test. So here we go. So we get one row for product 1 or total order volume 50 and one row for 70. All right. So that's basically what we're gonna have. Now, if we change this one from output mode complete to, for the streaming query, to the output mode update, let's see what we can get then. Or what we'll get then. So let's run this again. We will get one row for the first batch and one row for the second batch. It will simply emit the updated row. We actually won't see a difference from the complete mode because we only have one row for both batches. To highlight this, I will introduce a new transaction for product 2, so that we can get two in the complete mode. We will get 2 output rows for the first batch and 2 output rows for the second batch, and in the update mode we will get 2 output rows in the first batch, but only 1 row in the output for the second batch if we only update product 1, for example. So now we can actually see what's going on. So now it has failed. So the first start streaming query, output mode update. Here we see we updated product 1, and in the second batch we get 2 rows because this row for product 1 actually got updated. Let's see. Start streaming query, output mode, update mode. Write data to table, process all. All right. So let's add a transaction for no. Make this A3 and this A4. So customer 2 also bought product 2. Quantity is 1 and price is 1. So in the expected we want to have not only product 1 but also product 2. Total order volume should be 1, and the latest purchase timestamp is still the 1st of June at 11. So here's that. If we run in update mode, expected 1 should have 2 rows, and expected 2 should have only 1 row. Let's see. Here we can also check that the second record is actually also on the result. Is it running the right test? 2 batches, yes. Okay, let's see. And then we are basically done. So that's what I wanted to show you here. How we can basically, that's actually a quite complex unit test. Many people won't write a unit test like this, I guess. But I think it's very good practice to also, because if we are dealing with streaming data, we actually have some timing dependencies to when the records actually arrive. And also we have to actually think about the output mode, because depending on the data sync, so the place where we're going to write the data, depending on the data sync, we will have to use different output modes. So either we append new records or we update existing records if the sync actually provides functionality to do that. Or we can use complete mode to write the entire table all the time. So let's see what's happening. So now we get 2 records in the first, which makes sense. And then in the third one, we now have 3 records because we're using update mode, and we only get 1 update record for the latest batch. So the latest batch only shows us that we have updated product 1. So therefore, we have basically a record which is arriving later, which basically overwrites the previously generated aggregation record. And therefore, we will have to basically reduce the product 1, or basically all the products, to the latest arrived record, which we cannot easily say here in this example because we don't have any event timestamp or something. Then we could simply order by the event timestamp and choose the row which has been appended later. But we can use something else basically, but only for the fact that the total order volume will always be strictly increasing. So we won't have an order which doesn't add basically which doesn't increase this aggregation. Therefore we could simply sort by the total order volume and take the row which has the highest total order volume. And that we will have to do when we basically get all the data as dicts. We will have to basically filter this data frame. We have read here from the stream, filter it by the total order volume, and get only the row which has the highest total order volume. So that we can do, but that we will only have to do for this functionality we're doing here. So basically for the aggregations, but not for the filtering which we are testing in the same file here. That we can do, for example, by saying we want to implement a function which will reduce our records, or basically which will reduce our resulting data frame to only 1 row per product. And let me show you how to do that. So we need to define a function aggregate result, which takes the data frame, so the actual data frame. So that one's being read from the stream data frame, and it returns a data frame aggregated. And on that actual df, we say group by, and we want a product ID. And then we want to get basically, we need a window function for sure. So we want to say with column no, we don't want to group by exactly. We need a window function because otherwise we would have to do an aggregation again. But here we want to actually do a with column rank, and that should be done over a window. So we need a window specification, and that one we will have to import partition by, and here we do the partition by product ID, and then we say order by column total order volume, and that should be done descending. Now we need to import this one here. And PySpark, here we have the window in the SQL package, and we also need the function from PySpark SQL functions import call. Let me jump back here, and here we then use the rank. We need this one as well over the window spec. So I need to import this rank function as well. Let's jump back. So with column rank over the window specification, which will, and then we need to filter where the column rank equals 1. So only the first row, so the one with the highest order volume for each product. Product. And then we drop the rank again. And that one we return. And clean it up. Like this. So actually df with column rank filter and then drop the column. Now this aggregation we can only do if we test the aggregation functionality, but we cannot do it if we test the filter. So that's why we only want to apply this transformation if we have an aggregation test. And therefore we will make an optional argument to the process all as dict. So basically when we read the records from the stream, we can pass in, so the actual streaming df, which we don't need. It's not used anyway, we can remove it later. And we can call in aggregation function, which will be of type callable. And here we have data frame. Now we have to import this one from typing. So what that means, and the default should be none. So what that means is we can pass in an optional callable object, basically a function. And we want to pass this one in only for the aggregation tests. I will show you how to do that. So we don't need this actual streaming df here, only the query. Process all as dicts. Like this. So now here in this last test case which we saw, we want to pass in this aggregate result, which could be static. Let's make it static. We want to pass this in the process all as dicts. So here, aggregation function should be self, not this one, but aggregation function, aggregate result. And here we remove the parentheses because we don't want to call this function, but we want to pass this one in as a argument into our functionality where we read the stream as described before. Sorry. Like this. And also here, aggregation function, self, aggregate results. Let's see if it works now. Let's run this test. Is it online? What does it mean? Maybe the stream is not available. I don't know. All right, let's see. So now we're using the fact that the total order volume is always increasing, sort by the total order volume. But in a real use case, we would probably have something like an event timestamp or update timestamp, by which we can order, and then we select the latest row basically that has been emitted as the current state. Now we're kind of abusing or using the trait of our business logic basically. So the problem is, it still fails. It's simply because we didn't apply this function. So we never used it actually. So we're still simply using this data frame. So let's first read the actual data frame from the stream and then say if we have an aggregation function, we say actual df equals aggregation function of actual df. So only if we are provided an aggregation function, we apply it to the actual df, and then we get the dicts from that. So we simply forgot to apply our function that we implemented for that purpose. So now it should run. Okay, it's been a 1 hour stream. I thought I could make this in 20 minutes with you, but obviously not. Okay, I meant it is live. Great. All right, thanks for the feedback. This will also be recorded and available on YouTube, so people can view this later on. I'll probably do another live coding session next week, basically Thursday again. Just recording some videos, which will be available after that as well. But I'm always happy if you join. You can ask your questions. I would also be happy if you left some feedback, if these use cases are fine, if you would like to see something different. So we can have a look at different use cases as well. Oh no, I reformatted the file. So now on the expected, let's see. P1, all right. So we need this record in the output as well. Product 1. Okay, great. Thanks for the feedback. If you have any suggestions, what you would like to see, always let me know. All right. So yeah, as I mentioned, maybe this is too hard of an entry, but it's actually, take your time to walk through this again. But this is basically how I would implement a streaming use case in a more complex environment. So it's very important to have tests, especially for streaming use cases, because they are quite hard to debug actually. So you want to make sure that you get these timing dependencies right, and that you do that work once and you can reuse it for all the functionality you basically implement. So while this may appear as a lot of overhead, this is a very important foundation for developing high quality streaming queries. I also would like to point you towards my academy, which you can find at, let's move this one here, which you can find at academy.philipp-brunenberg.de. I actually offer Spark coaching. I will work with engineers for 12 weeks, make them pro-level data engineers, Spark engineers. We will do one-on-one live sessions, and I will show you everything I know about Spark. If you scroll down on this page, there's some testimonials of people I've worked with. So here's the individual coaching in Apache Spark, where I will teach you everything you will have to know, starting from the internals, developing simple batch-oriented Spark applications, also deploying applications to the cloud, performance optimizations, streaming, working with various data sources like also data lake and stuff like that. So if you're interested, check it out at academy.philipp-brunenberg.de, and we can schedule a call and see if that's for you. All right. Having that said, I thank everyone who has tuned in. I hope you could take something away from this. You can walk through this video again on YouTube if you like. Otherwise, we probably will see next week if you like. And yeah, I wish all of you a pleasant day or evening. Until next time, thank you again. Bye bye.